Find Q and R for the following pair of positive integers A and B satisfying A equal to BQ plus R. A is equal to BQ plus R. A equal to given 13 and B is equal to 3. The solution is B is A equal to BQ plus R. What is A? A equal to 13 and substitute the value of B equal to 3 and B 3Q plus 1. That means 13, 3 4 times is 12 and plus 1 is 13. So we can write 3 into 4 plus 1. So what is Q? Q equal to 4, the remainder is 1. Now observe this. 13 is divided by 3, that means 3 4 times is 12. So remainder is 1. We can write this 3 into 4 plus 1. 3. We can write this 3 into 4, remainder is plus 1. 3 into 4 plus 1. Second one, A equal to 80, B is equal to 8. 80 equal to 8 into 10 times. 80 is, we can write 8 into 10 times plus 0. So there is no remainder here. So we can write this is A is equal to BQ plus R. B is 8 and Q is 10. The remainder is 0. So hence Q is equal to 10. We can write R equal to 0. Now observe this one. A equal to 125 is given. B is 5. So 125 is equal to, we can write 5 25 times is 125 plus there is no remainder equal to 0 or equal to 0. Hence that Q equal to, this is the Q value, the BQ, A is equal to BQ. So we can write Q is equal to 25 or equal to 0. The next one, A is equal to 132, B is equal to 11. 132 is equal to that 11 table, 11 12 times is 132 and plus 0. Now compare this equation with A is equal to BQ plus R. A equal to BQ plus R. What is A? A equal to 132 and in the place of B equal to 11, Q is equal to 12, R is 0. So Q is equal to 12 and R equal to 0. Find the HCF of the following by using Euclid algorithm. 50 and 70 is given. Which is big one? You should take the big number is A and small number is B. So for given two positive integers where A is greater than B, there exists unique pair of integers Q and R satisfying the equation A equal to BQ plus R, where R lies between 0 less than or equal to R less than B only. Now A is 70 because 70 is greater than 50. So B is 50. Here A 70 is equal to, we can substitute these values in this equation. A equal to 70 and B equal to 50 and 70 is equal to 50. 50 is one time is 50. 50 two times is 100. So it is not possible to take where Q equal to 2 because 52 times is not equal to 70. So 51 time is 50 and a remainder 70 minus 50, that is remainder is 20. 50 one time is 50 plus 20 is 70. So we can write this equation 70 is equal to 50 into 1 plus 20, where A is equal to 70, here B equal to 50 and Q is equal to 1 plus R equal to 20. So we can write these values, but we should continue this until get remainder is 0. Now this is remainder is not 0, 20 is there. Now consider this b and remainder is 20. So 50 is greater than always because remainder is always less than this a comma b. So now consider this 50 and 20. So 50 is equal to 20 into 2 times we can take. But 20 into 3 times is not possible because 20 into 3 times is 60. 60 is greater than 50. So we should not take 3 times. 20 into 2 times is 40 and remaining value is 10. 40 and 10 is 50. So 20 into 2 times plus 10. Here a remainder again is not equal to 0. Now take again this 20 and 10. Now 50 and say equal to 50 here and b is 20, q is equal to 2 and r equal to 10. This is q value and r value this one. Now take this 50 and 20 and remainder is 10. Now taking 20 and 10, 20 is equal to, we can write 10 into 2 plus 0. So we can 2 times is 20, there is no remainder. So we should continue this same to get remainder 0. Now the HCF, highest common factor of the 70 and 50 is this value. Here the remainder is 0. So we can take this 10 is the factor of HCF of those two numbers. 10 is the highest common factor of 70 and 50. Now we will take another example, that is 96 and 72. 96 is equal to 72 one time. Here's a and b. Which is a? The biggest value is a and smallest value is b. So we should write in the form of a equal to bq plus r. bq plus r. So what is a? 96 is equal to 72 one time is 72 and we need to add some value to get this 96, that is 24. 72 one time is 72 plus 24 is 96. So here is remainder is not 0. So we should continue again this take this b value here and the remainder should be taken as b. So 72 is equal to 24 3 times is 72. Now the remainder is 0. What is the this is called the, when the remainder is 0, this b value is HCF. Now 96 and 72, the HCF of 96 and 72 is 24. Yeah, now take another example. This question, 300 and 550 is given. The bigger value is 550, so we can write in the form of a equal to bq plus r. The value of a is 550 is equal to b is 300 into 1 time is 300. 2 times is not possible because 2 times of 300 is 600. So here is only 550 is there. We cannot take the 2 value because it is bigger value. So 300 into 1 time is 300 and 550 is there. 300 and remaining is 250. 300 into 1 time is 300 and 250 is 550. The 550 we can write 300 into 1 time plus 250. So remainder is not 0 here. We will take again this 300 is here. We should take 300 to here and the remainder should be taken here. So 300 is equal to 250 into 1 time is 250 and we should add 50 to get the 300 value. 300 is equal to 250 1 time plus 50. So again remainder is not 0. Again take the value of 250 is here and 50 is here, b value. The b value becomes a value and the remainder becomes b value. So 250 is equal to, we can write 50 into 5 times is 250. Now the remainder is 0. So when the remainder is 0, this b value is known as HCF. HCF is equal to 50. The HCF of 300 and 550 is 50. Now take this example. 1860 and 2015. The big value is a 2015. That is a value 2015 is equal to 1860 one time. It is possible. So 1850 one times plus, to get 2015 we should add 155. So it is not 0 and continue the same. 1860 and this value, remainder value becomes b. 155 into 12 times is 1860. 155 into 12 times is 1860. So remainder is 0. Now this 155 is called HCF. What is the nature of Q and R? Given that A, we know that A is equal to BQ plus R. What is the nature of Q and R? And Q is always greater than 0. R must be equal, R is equal to 0 and it is lies between 0 and B. Q is must be greater than 0 and R lies between 0 and B, equal to 0 but not equal to B. So Q is greater than 0 and 0 less than or equal to R less than B. Yeah, can you find the HCF 1.2 and 0.12 by using Euclid division algorithm? Justify your answer. No, because we know that a comma b are the positive integers. We know that. Now it is not possible to find the HCF of 1.2 and 0.12 because by using Euclid division lemma, division algorithm, because Euclid division lemma to find the HCF is applicable only for positive integers. Theorem. Division algorithm. Given positive integers a and b, there exists unique pair of whole numbers q and r satisfying that equation a equal to bq plus r, where r is lies between 0 and 0 or equal to 0 less than b. What is that? Division algorithm theorem. Given positive integers a and b, there exists unique pair of whole numbers q and r, but q is always greater than 0. So satisfying a equal to bq plus r and 0 less than or equal to r less than b, not less than or equal to b. We should write only less than b. Show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1, where q is some integers. We know that 2q, the multiple q is, what is q? Q is positive integer. We know that. We can take 1, 2, 3, 4, so and so. If you take q equal to 1, 2 into 1, we will get 2. So 2 means 2 into 2, that is 4. And 3, if you take a q value is 3, 2 into 3, that is 6. 2, 4, 6, 8, these are the even integers, we know. And 2q plus 1 means 2 into 1 plus 1. That means 2 plus 1 equal to 3. 2 into 2, 4 plus 1, that equal to 5. these 2, 5, 7 we will get, these are called odd numbers. Let a be any positive integer and b is equal to 2 is given, because a is equal to given, that is 2q. So 2q is given. Then by the division algorithm we can write a is equal to 2q plus r. For some integers q is greater than or equal to 0 and r equal to 0 or r equal to 1, because 0 here is b value is 2, so 0 to 2 only we will get the values are only 0 to 2. 0 only 2 is not possible to take because it lies equal to 0 but less than 2, so we can write a equal to 2q or a equal to 2q plus 1. If you take r equal to 0, a equal to a is equal to 2q plus 0, that is a equal to 2q. If you take r equal to 1, a is equal to 2q plus 1. This is, we will get these two values only. If a is of the form 2q, then a is an even integer. Also, a positive integer can be either even or odd. Therefore, any positive odd integer is in the form of 2q plus 1, and any even integer is in the form of 2q. So that every positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. Now look at here. It is in the, if you write it is in the form of a is equal to b q plus r. Here is the value of b is 4 given. The value of b is 4 given. We should take the r values always lies between 0 and less than b. Less than b means 4. Less than 4. That means 0, 1, 2, 3 only. We will take 0, 1, 2, 3. Now let a be a positive odd integer and b equal to 4 is given. We apply the division algorithm for a and b, where b equal to 4. That means a is equal to b 4q plus r, because already 4 is given. 4q plus r. What is the value of r is lies between 0 and less than 4. So q is greater than or equal to 0 and 0 less than or equal to r less than 4, not equal to here 4. The possible remainders are 0, 1, 2, 3 only, not 4. Now apply this in this equation. A is equal to 4q plus 0. That means a equal to, we will get 4q1. And if you take 1, a equal to 4q plus 1. This is the next value. And if you take the value r equal to 2, a is equal to 4q plus 2. This is the next value. If you take 3, a equal to 4q plus 3. These are the a values we will get, and 4q plus 1, 4q plus 2, 4q plus 3, where q is the quotient. However, since a is odd, a cannot be 4q. A cannot be 4q. Why? Odd. If a is odd number, and this value must not be 0, 4q. The 4q, here the 4q is, if you substitute the value of 1, 4 into 1, we will get 4. 4 is not odd number. If you take 2, 4 into 2, 8. 8 is not odd number. So 4q cannot be 4q. A is not odd number. So which is equal to 2 into 2q. 2 multiples, all the 2 multiples we know even numbers. 2 into 2q. That means always 4q is even number. And the next one is also 4q plus 2. If you take the common 2, we will get it is which is equal to 2 into 2q plus 1. 2 into 2 4, 2 into 1 is 2. This value we can uh, written as 2 into 2q plus 1. Here is also one value is there. If we multiply with 2, we will get the same value, that is the even number. That means this 4q and 4q plus 2, these two are always even numbers. Now observe this 4q plus 1. If you take q equal to 1, 4 plus 1 equal to 5. If you take q equal to 2, 4 into 2 plus 1, 8 plus 1, 9. This is odd number. Now here is also, if you substitute the value, q is 0, 0 plus 3 is 3. And if you take 1, 4 into 1 plus 3 is 7, is also odd number. If you take 3, 12 plus 3 is 15, is also odd number. That means 4q and 4q plus 2 are always even numbers, and 4q plus 1, 4q plus 3 are always odd numbers. So therefore any odd integer is the form of 4q plus 1 or 4q plus 3. Use Euclid division algorithm to find the HCF of 900 and 270. 900 is a value, 270 is b value. So we should write in the form of a is equal to b cube plus r. When the remainder is 0, the b becomes highest common factor. Now we can write a is equal to 900. So 900 equal to 270 3 times plus 90 equal to 900. 270 3 times is 810 and plus 90 is 900. Now remainder is not 0. So again take 270 is b as a and remainder as b. So 270 is equal to 90 into 3 times is 270. There is no remainder, equal to 0. Now when the remainder is 0, this b value is called highest common factor. Now see this example. 196 is equal to 38,220. This is a big value. So take a equal to 38,220 is equal to 196 into 195 times is 38,220. So there is no remainder. So what is the HCF? This b becomes HCF. Therefore 196 is the HCF of 196 and 38,220. Now another example. 1651 and 2032. A equal to 2032. So 1651 one time in 1651 plus if you add 381 we will get 2032. This is equal to 1651 plus 381. So remainder is not 0. Then continue. 1651 you should take here and the remainder should be taken as b. 381 1651 is equal to 381 4 times and the remainder is 127. So remainder is once again it is not 0. Once again take 381 is equal to remainder should be here 127 3 times is 381. So now the remainder is 0. Then the highest common HCF is of 1651 and 2032 is 127.